practice, and then we will have some new topics. After a few minutes, Dr. Atul Dwivedi sir will join, and we will continue with new topics. Till then, let's revise some topics from last class, that was on Saturday. Basics of Matlab, some plotting concepts, and some signal generation concepts. How to plot a signal, discrete signal as well as continuous signal. So if you have solved, then it is okay. If you're not, then you can turn on your laptops, you can turn on your Matlab, and we can start solving. I hope you have joined Google Classroom. If you have not joined, please send your Gmail account, Google account, so that we can add. Some of your Gmail IDs have some errors. We got errors during sending the invitation, so we can try again if you provide the Gmail again. Okay, so I think we should start with some practice. If we have
One thing I just want to announce that those participants who are not in a Google Classroom, you can just call me, or I can share my mobile number on WhatsApp group, so you will be free to call to join in the Google Classroom. Thank you.
Okay, thank you, Assis sir. So it's okay. Let's start with some basic problems from last class. I think we can start, Ashish sir. There are 18-19 participants now.
Yes, sir, we can start.
Okay. I hope it is visible to you.
Yes, sir.
Okay. So we have shared this Google, what do we say, this document sheet in GCR. So if you have not gone through, please write down no in chat box so that I can have a revision on these commands thoroughly, just brief. And if you have gone through, I will move forward for some more examples. Some of the participants are from our batch 1. Okay, that is nice. Some of our participants have already joined, already attended our fundamental course, so they might know some topics. Let's have some time for new participants here. Here I have shared some commands with help. So you can see that help, CLC, clear, these are very simple things. Let me go for help plot. Okay, means this is a very important part in signal processing, because we need to plot each and every kind of data whenever we want to process. So we are going to have a brief review on these functions, these commands. First one is help plot, means it will give us some details, related details on plot. So just I am giving some time here. If I write on command window help plot, what will happen? Let's see. Yes, there are different what do we say, helps are here provided by Matlab. You can see this is for linear plot, that is continuous plot, and by default it will plot a signal with its index, that is our position, and we have some notations, the colors, the what do we say, markers, as well as the line type, that is solid, dotted, dash dot, something. Okay, uh, if we go for some more formats, so we can write like this. If we have a single plot, we can write like this. If we have multiple number of plots, then what will be the sequence? The sequence will be x1 y1, and s1 is actually this format. So if I write x1 y1 x2 y2 x3 y3, it will plot all the different plots inside a single plot command. It's not very tough, so just I'm giving a brief review here. Okay, and now if I go for help stem, it will give me some details about stem plot. Here my stem command is given. If I stem y, if I go for any plot with a single command, with a single variable, it will by default plot that data with respect to index. If I go for the x and y both data, then it will plot generally as we see generally. So there are some more specific command here. We can say this part actually. Let's move for next thing. What we have in our practice sheet. Help look for, this is a very new command to you, I think. Actually, look for will give some details about your file. If I go for help, look for, what will happen? Okay, here we can see that look for search all Matlab files for keyword. If I provide any particular keyword here, look for, and if I say plot, or look for, I think a plot is better. If I enter this, what will happen? It will take too much time, because it will search all possible files and folders here. So I think it will take too much time. Okay, if you want to search any file with a particular keyword, then you can do that. I'm just aborting this. Okay, I'm just aborting this so that I should not waste my time here. Okay. Yes, recording has been started. Don't worry. So here are some basic commands. Now these are some basic commands, basic functions on matrices, matrix operations. How to define a vector or matrix, since these are we are using semicolon here, means it is terminating it to next row. So this is our how to define a matrix. If I go for just this command, if I just copy and paste it here, it will give me a matrix. We can see the size here over here. So if I go for size command, what will happen? It will give me the actual size of this part. So 3 rows and 3 columns. And just what will be the indexing part? If I go for 3 comma 3, can anybody tell me in chat box what will be a 3 comma 3?
9.
Okay, very nice, nice one. It is 9. Or if I say a end, if I go for just end, what will happen? I'm not giving a row number or a column number, just I'm getting for end. Okay, it is the same thing. It is 9 because the end element is this 9. Okay, so these are some basic from matrices. This x is equal to 0 colon operator. Now we are using the colon operator. This is a part which is useful for a vector generation. For example, if I say 0 colon 15, it will generate 15 data here. Okay, similarly we can generate a number of data to get a signal. Let's move for some commands in plotting. Actually we have seen some plotting commands over here. We have to go for we have to generate a vector, that is x vector. We have to generate another function that is either output or our y vector. Okay, so using those we can go for plot. Now let's move for some examples in signal. Yes, I have seen here. We have already seen that in last session, so I'm not giving the same thing repetitive. If I go for some shifted signal, okay, that is delta signal, discrete time signal, delta n plus 2. We have seen this. If I go for delta n plus 3, I have given this in our exercise. So how to go for that? How to generate that signal? Here my question is that how to represent this x4n is equal to delta n plus 3? How to generate this signal? So it is a discrete signal and it will give me the response impulse signal at -3 time. So here I am sharing my solution. It is solution number 2, I think. Yes. So here I have this solution for that. I have to define the x-axis values. My range is -5 to +5. Okay, if I go for delta n plus 1, that means what to do? Just I am running the program. Let's run the section. Okay, I'm getting the plot over here at point 1, positive 1. That means the time is n is equal to positive 1 here. What to do? For this particular range, I have to define some 0 values except this point. That is for point 1 we have to define for point 1 we have to define 1. For other points we have to go for 0. Therefore I am creating 0 matrix with 1 row and 6 columns. Similarly for here part. So this is how to generate a discrete time signal. If I go for some more functions, you can see here one by one we can go. Yes, this is n plus 3 command for delta n plus 3 signal. This is figure number 4. Figure number 3, it is delta n plus 5. So it is giving us a single unit command, a single unit impulse at -5 time. For delta n minus 4, it will give us here that n is equal to 4 point. Similarly, we can generate some shifted signals. We have seen already. I will share these solutions to you also so that you can verify your codes. Okay. Here some our continuous time signals are given. For xt is equal to sine pi t upon 4. And it is very easy. We have to define just t and then plot. You can see the result. That will be easy to understand. Yes, just we have to give a time vector and then just we have to plot the this plot function. Okay, that is output. Now if I go for plot, it will give me a continuous plot. So it is nothing too much tough to understand. If I go for some unsolved examples, that is, those are do-it-yourself problems. Consider the following signal xm n is equal to sine of 2 pi m n upon capital N. Now, where some data is given here, n is equal to 12, m is equal to 4, 5, 7, and 10. Now, these m values are terms of vectors, that is, values of a vector. So we have to give individually the data. That means we have to define capital N, we have to define capital M, we have to define this small n also. Okay, so here n ranges from 0 to 2n minus 1, m is equal to 4, 5, 7, and 10, and then 9, n, capital N. So in this way, if I go for a plotting, go for the programming part, what will happen actually? Yes, I have to define this capital N, I have to define this capital M, as well as the small n. Now I have defined all the required variables. Now I have to go for the function here. Xn is equal to sine 2 pi m1 n by 2. Actually, here I'm indexing 1, indexing m, because m has 4 values, and I have to calculate each and every plot for each and every data. So at first it will take 4, at second it will take 5, then 7, then 10. Similarly, I can go for 1 plot. Here I have 4 different plots. First m1, then m2, then m3, and m4. So if I run the program, what will happen? Let's see. Okay, I will get 4 different plots here. One by one, you can see here. Yes, these are 4 different plots. For m is equal to 4, it is giving some data like this, discrete plot actually. And for m is equal to 5, this kind of plot, m is equal to this 7, and m is equal to 10. These are some different plots. We have to just observe the data, that how the plot gets changed according to our data provided. Now, according to this plot, we can observe that what would be the fundamental period of a signal. At what time the signal is going to be repeated, we can say that is exact one. Okay. I think Dr. Atul Dwivedi sir had joined. So I will go for one more example, and then we will continue with Dr. Atul Dwivedi sir. Our last example is here. Some data is missing over here. You can multiply here 2 pi k into n. That is important part. That is quite by mistake it is missing. So consider the signal xkn is equal to sine of omega k of n, and where omega k is defined by 2 pi k multiplied by something is missing here, n is missing. So you have to define 2 pi kn upon 5, and it is a kind of signal, and we have to just plot and we have to identify that. Okay, so if I go for just a subplot function, how will it work? Because for plotting it is a very necessary and important tool, that how to go for a subplot. So I have defined k, I have defined omega k, and then go for sine. So if I plot, I can see that in first position I am getting the result of this part, this first plot, and then for second one we are getting the second plot. So it's not too much tough to understand. And I think nothing is missing here. Some question part is missing here, that if two signals are identical, explain how different values of omega k can be in the same signal. So we have to just observe that. And how many unique signals have you plotted? You have to check for that, because I have plotted only 2 signals over here. I can go for 2 more signals. Let's copy it and paste it for 2 2 3 and plot number 3, and the number 1 it is 4 and plot number 4. Okay, I will get 4 different plots. So I think that our plot 1 and plot 4 both are quite similar. So we can check out using plot YY function. Plot number 1 and plot number 4, we are getting the same plots. So we can check out using our plot YY function. So I think we are at the ending of this practice part. This is just a review. I request you all to have a practice on these topics after this session. If you have not done, if you have done, then it is okay. We will share another practice sheet on today's topics. So if you have any queries, Dr. Atul Dwivedi sir is here. I think, sir, we can start with our next lecture, next topic.
Yes. Very good evening to everyone. We will start the session. If you have any query, question in this practice sheet or from the last session, you can ask now.
So there is a question in chat box.
Yes.
Del not taken for discrete signal. Actually, I couldn't understood the question. Prachi, ma'am, can you repeat?
I think this is not a question. There may be some in between some comment over the some solution.
So the very first problem, Panda sir, when you explain, so I thought del underscore we have to take. I thought so. I asked that.
Okay. Yes. That's what I thought, that this was not a query. This is actually some comment over the solution. Very nice. So today we are going to discuss some more over the signals, and I will take audio signals also today for demonstration, and how to record audio in Matlab, how to plot audio in Matlab, how to read an audio file in Matlab, and how to write audio file into the Matlab. So, and also I will display ECG signal, and also I will cover a reading signal from a text file and a reading signal from any Excel data. Sometimes what happens that data is available in Excel sheet or somewhere. So that time we need to see the data from Excel sheet. So, okay. So let me share my presentation. Okay. So this is the presentation. This visible. Okay, very nice. So I think now my screen is here.
Yes, sir. It's here.
Yes. So that we can continue and can see that this today module section 2. So today we will discuss how to represent a signal if signal is available in Excel file, in text file, and also a discussion over the audio signals. So this all we shall do in today's class. So that is what the agenda of today's class. Then I will discuss. First thing is that the signals are many times available in the form of Excel sheet, and in the form of the data like Txt file, because the sensors provide data and we have separate softwares many times like Arduino and all. So we get the data in the form of Excel sheet or some form, and then we save it into the Excel sheet and like that, or we can save into the text file similar to that. So these are coming from the sensor devices, some sensors that where we take the data, and then this data, when it is to be imported into the Matlab, so how it is done, that is what, and how it can be plotted, that is the topic of discussion today. Okay, then we'll see that how the data from Excel sheet can be read and how can it be plotted. So that we'll do in the Matlab. Then we'll see that this is the coding for how to do that thing in the Matlab. So there is a command of XLS read also, and we can use the command read table also. So read table command we'll use to read the data from Excel sheet, and then to display into this header one will be saved into the X data, and header 2 means second column will be saved into the Y data, and then simply plot. So simple. This is not nothing difficult in Matlab to do. So here also we will do simply we will take data. For reading the data, the command is read table, and this is the file name that is available into my current directory, and then which sheet I have to take from the Excel file, that sheet name should be given. So that is what is written here, that sheet 1. Then get this column 1, header 1 into X and header 2 into Y, then plot X. Let us go to the Matlab and do the things. Okay. So where is my Matlab? This is, I think that is not opened yet. I will open Matlab. No, Matlab is there. Okay, so this is the Matlab. Here we are going to do to read a data from Excel file, Excel sheet. I'll just close all those previous files. Okay, so in my current folder, you can see that one test data I have saved. Now you can go to your work folder wherever it is. For example, if you have desktop, if you are having this work folder in the desktop, so go to the place wherever you have work folder. In the work folder, you just have to right click and create a new Excel file. So test underscore data, whatever test for testing, whatever name you want, you can give name. So test underscore data name you have to give, and then after you can open this Excel sheet, and then you can save the data into the first header and second header, means first column and second column, something data. Whatever data you want to save, you can save for just for learning purpose. We are saving this data like that, test data. So then one file will be there in your current folder. One file is there which have some data. Okay, so here also I have one data for testing. I can show you in Excel that one also. That this is actually this data is saved into this file. So this one can be used for plotting. This is what I am using for plotting. So this is some plot will come from this data. So this this is some data I have just copied from my sensor to this place and saved it here. Okay, I will close it, To read this in Matlab, let us open one my program 01. So first program here, and then you have to read the data first. So my table, any name you can give to the variable. So my table equal to read table command we will use for to read the data from the Excel sheet. Read table, and what is the name of whatever name you have given, you just see the data name should be there in your current folder. You can click press F2 button of your computer, or you can just right click over here and rename, so that it will select the name, and then right click and copy, because the name should be exactly same. If name is different, it will not work. After name, the file extension we have to write. So a file extension is here XLX. So there are two kind of files. If you are using old version of Office, then it will be XLS. If you are using newer version, is XLX. So you have to take care of that. Whatever the name of the file is here, that same name should be there in your program. Then you have to write sheet, and in the sheet you have to write which sheet you are using. So we have to write here that we are using sheet 1, then we have to write sheet 1 here. If we are using sheet 2, then we have to write sheet 2 there. Okay, so I am using sheet 1, so I will write because we have just created a file which is using only sheet 1 only. So this will read the table. Let us see one by one, step by step, what is happening. So this is now. Actually, my voice is already saved in this, so it is better to leave it. Just FS and this my table. FS is not part of this program. This is part of the previous program. That is why we should always use CLC and clear, so that you will not be confused with the data that data is from this program also. So my table is now is there in your workspace. So it is now there. It is successfully read by Matlab. Second thing we have to do that we have to save X and Y value. So X is equal to my table, whatever table we have read, dot header 1. So in header 1 or first column, whatever data is there, that data will be saved into X. Then we have to use Y, my table dot header 2. Okay, so but the means we got the data from X for X and Y both. So that now we can plot. You can see that the size of X and size of Y is same. So easily we can use plot command. Now we can write command plot of X comma Y and hit the run button. It will plot the signal, whatever signal you have in your Excel sheet. One more, because I will be discussing audio also today, so I will just experiment how does it sounds. I don't know whether sound is also shared or not. Sound of say why. It's a very small sound. I will show you a good sound also later on. No problem. So this is how we can plot the data from Excel sheet. Okay, and we now next thing is how to read data from Txt file. So
Sir, there
if
is a
you have
question.
data in a txt file, I will share this txt file in the Google Classroom so that you can download for your experimentation. Otherwise, you can save also. I will tell you the way how to save. I have just saved it from the Matlab only, but this data can be obtained from other places. Yes, this is exponential
Hello,
data.
there is a question, sir.
Means just I have some data here, and by separated by space, some other data is also there in the txt file. Okay, so how to access this text data by Matlab? That can be done with the help of this program. I have already written program, so this is very simple and 3-line code. So you all can write the same code in your computer and see. So how can you experiment if you don't have this file? Okay, is this Excel sheet clear, or any question is there?
Sir, there is
Sir,
a
I had a question. Sir, in the previous file, Excel sheet file, I had a question that what is the purpose of sheet and sheet 1? You have explained it, but can you please explain it again?
No voice. Hello.
Hello.
Okay. Let me check out.
Sir, actually, she's asking for what you are saying about sheet and sheet 1, sir. Sheet and sheet 1.
My voice is coming or not?
Sir, your
voice
Yes, sir, your voice is coming.
Yes,
Are you
sir.
getting my voice?
Yes, sir. We can hear you.
Okay.
In Excel sheet, we have to write what sheet we are using. That sheet name is he has mentioned. That's it.
Yes, sir. My question was why do
My
we
question
have
was
to write the
why do we
option
have to
sheet and sheet
write
1?
the option sheet and sheet 1?
I don't know why my mic speaker is not.
Speaker is not.
Okay, so I'll just try to. Okay, my you are getting my voice?
Yes, sir.
Yes, sir.
Okay, then let us continue. I can see the questions in the chat. One question is that what is sheet and sheet 1? See, sheet and what is the meaning of sheet and sheet 1? Let's just see window. I will go check. Go to my. I have already opened one Excel sheet. So you can see if I go to this mat file and I had created this Excel sheet. So in the Excel sheet, always there are some. See in the Excel sheet when we open, so in the below you can see here there is a sheet 1. Okay,
Yes, sir.
and here then if you can have many sheets in one Excel file. So some data may be in sheet 1, some data may be in sheet 2, some data may be in sheet 3, and then you have to select sheet from which sheet you are taking the data. That is what is a syntax is there in the Matlab that you have to write which sheet we are using for our extraction of data. So here this is the syntax that you have to specify. So sheet I am writing because I am specifying sheet number after this sheet. So this is specifying the sheet number. So yes, is this clear?
Yes, sir. It's clear. Thank you.
Okay. Okay, nice. Next thing we are doing that we are dealing with the text file. So one text file is there in my current folder, exp.txt. Just I am opening that text file. fopen command is to open the text file. This will open the text file. Let me check something. Okay, let me check my settings. Just for audio setting, I will check. Okay. So we are here, and that this is doing fopen, and then exp.txt is file name, and then we have R. R means this will open in read mode. If you are writing the text file, then we have to write W here. If we are opening for reading some data from the text file, then we have to open in read mode. R refers to read mode. Okay. Then here I am using a text scan function that will scan the values in the text file specified by this variable file ID. File ID, I have taken one variable. Okay, and then this is the format specifier because there are two values. So first percentage 6.2f means that we are taking a 6 point. That means, let me tell you that suppose a number is being read, then we are giving a space of 6 points. Means there are 6 places will be available into the 6 places will be available into the number, and 2 out of these numbers, 2 places are for the decimal points, and F refers to floating point. See, there are some floating point and double, float, character, decimal, D for decimal, like that. So this F refers fractional or floating point number or double decimal numbers. So similar to that, in the right side, the second number will have the second part of the this will be that will be having a bigger, it will be having 12 values. Out of these 12 values, we are giving 8 for the fractional. Total there are 12 digits. Out of that 8 can be used for fractional part. That is what this means. Okay, then this will come into A. A will have 2 values. So the first value is plotted with respect to the second value. Let us do, then see what comes. Let us do this before plotting. I am just commenting the plotting part and then running this program. So what is happening? That A is having a cell type of data which is having 2 values, 1 cross 2, that is having 2 values. So the first value I am accessing with the curly braces and second value with the other curly braces, and then plotting it. So it will plot this. Okay, so this is how we can access the text data from any work folder, any folder available. So actually I had written this text from the Matlab itself. You can write also text data. Suppose you want to save your results in the text file, then you can save into the text file. So this is the place where I have done this thing. The data is created between 0 and 1. I hope every one of us is familiar with this colon operator till now, because it is a very, very useful operator, and we use it many times. So you all are familiar with this. So we are starting with the 0 and going up to 1. Then I have created one variable a, where I am saving x and then exponential of x. In the, what it means, x semicolon expx means I am saving x and one column and expx in the other column. Okay. So then, sir, I will come back to this exp.txt, reading of exp.txt. Currently, I am discussing how to write if text data. If you want to write data into text, so just I have just here created the data. Just created x, then created a. Okay. Then just how I am doing this file handling. This is actually called file handling, and file handling, then how to read file and how to write files. So for that you have to open file and you have to close file. So here I'm just opening a file, exp.txt. What it will do, it will immediately create a file with the name exp.txt in your current folder. And then I am writing it with this fprintf command. Fprintf command will save the data into this file, the value of a into this file in this formatting structure. This is formatting structure. That is what what I have just explained to you all, what it means. And then f close file id. This will close the file, and file will be saved into the. Suppose exp.txt is not there. Suppose it is not there. I'm just deleting it. Okay, so it is saying that it is already opened into the Matlab. How can it delete it? I will just right click and try it to delete. It will not allow me because it is being used in the Matlab. But you can write with the new name and give myexp.txt just for understanding purpose, and then run. When I execute it, it will save one more. It should save one more file. I think, let me see. See here, the name, the file is now here in our current folder. Okay. So it is clear till now that how to read data from txt and how to write data in the txt. If there is any question, you can ask.
Sir, how to convert text file into mat file?
Very nice. So this question, that how to convert the text file into mat file, the way is that just import the data into the Matlab, then save it as mat file. You can save as mat file. I had discussed this in the last class, that how to save any data as a mat file. You have to just read the data like this. Here I have read the data from the file and stored it in the workspace. From workspace, you can save it as mat file. There is no direct command to convert, but you can save it like this. So this is now mat file is there. Kapil.
Sir, if we have multiple text files, then how?
Yes, you have to read, and there is a command to save as mat also. You can save. Means you can write a program in a loop, and then all the files can be read and done. All the files can be read and done. Okay. Okay. Any other query? Yes, hand raise.
No, sir, not now.
So can we convert the mat file to text file, sir? Reverse.
Can we convert a mat file into text file? Yes. That is what I'm telling, that we can save data into the text. Just I have created the data.
No, I am
all the
having
data in
only mat
file.
file. I am only having mat file. I have to convert that into text.
Yes, if you have mat file, suppose for example here I have mat file. Okay, my exponential dot mat, and you want to I will clear all the things from the Matlab there is no data this time, and then you want to convert this mat file into the text. What you have to do, you just bring this into your command window, just drag it into command window, it will come into the Matlab, and then you can save this variable into a text data by using a program like this program like this. So here A was a data only, actually data in the workspace, so that data can be saved as text file. Any name can be given here, and this A can be saved now, no problem. So mat file can be converted into text file. It can also be converted to Excel file. Excel file can be converted to mat file. There is no problem. So all the data can be saved and analyzed in this way. Okay, I think these things are now clear, that we can convert any text file to mat file to text file, and Excel file to also mat file, mat to Excel also. All those things are possible in Matlab. Okay. Now next thing, that is what we are going to discuss. That is that how can we do plot ECG signal in Matlab. So ECG signal is generally taken from the databases. There are many databases available for ECG signal, and also ECG devices. ECG devices may provide data in Excel sheet, or may provide data in a text file, or may provide data you directly into the Matlab. So Matlab also have interfacing with the many hardware devices. So many times Matlab directly connected to the device, then you will get data directly as a mat file directly in the workspace. Then you don't have to worry about the importing of the data. And most of the time researchers work on the standard databases. So Matlab have given one database, that is in the Matlab library itself, MIT BIH database is there. So that what I will show you, that how to plot a data of ECG from MIT BIH database. So to load MIT BIH database, we have to use a command. We have to use command load. Load command is used to load any data. Suppose you want to load any data into the program, then you can write load command. And in Matlab, this MIT data is already defined for ECG as MIT 200. So when you write load MIT 200, this data will be available in the Matlab. Before this, I will do CLC and clear, so that the previous data and previous variables will be deleted. And close all, to close all windows except the desktop. Then the run button. I will say my program number 2. This is to what is happening. What change happened? Just you can see the workspace that we got some variables. A large data of 10,000 double type, it's now loaded into the Matlab. Okay, so this data have TM is time marking, This with respect to ECG signal, this is time marking. So you all know that how to plot this. How to plot this? I have to, because this is a continuous signal, I have to use time in x-axis and ECG. See the variable name ECG sig. So I will write ECG sig only. Whatever variable is defined in this data, that only I have to write. Okay, so ECG sig, and then let us run it and see. This is actually ECG signal. Okay, so this is a ECG signal. You can there are many cycles in fact in this, so we can take a part. You can zoom it and see whether this is actually one ECG signal. Okay, I'm just showing. I'm not doing analysis now. Although in this database itself there is analysis available, some kind of analysis is already there, that they find out the peaks. So the third data that is there, this ENN, this is actually a annotation into this ECG signal. Wherever there is peak, the peaks are already found, and because the total peaks here are 41, and these 41 places have been marked already in this. So I will show you that what is the use of this. You can see the marked kind of ECG if you use this third. So if you use this third variable, that annotation, so means we'll do what I am doing. I am plotting only those points which have annotation. And okay, so we have to keep the previous one also. This one also. Then I have to use hold command. Hold on. It will keep the previous one. Then over the previous one itself, I will the plot annotated one. So the point of ECG signal which are annotated can be plotted by using this command. So this should show the annotation also. Okay, so this is actually tracking the peaks. So better to better to see the without any line, and let us give some let us make it red, so that red and the point should be circular shape. Then I think it will look better, because that continuous line was not looking good. That peaks are annotated. Now the peaks of this ECG are annotated. Yes, Kapil, there is find peaks command. To find peaks in any data, find peaks command is there, Kapil, so that you can find peaks in any data, means any signal, not only in ECG.
Thank you, sir. Thank you.
But yes, you can explore there are different syntax in that, so that you can. Here it was already available in the database, therefore I have directly used it. But otherwise, you have to find these points, these 41 points which have been found by someone, so already available here. That's why I have not used find peaks command in this. No issues. This was a ECG signal. Then we are going to discuss audio signals. Okay, so audio signals in the Matlab can be recorded and can be already recorded signals can also be analyzed. So first of all, before going to the already recorded signals, we will go how to record it into the Matlab. We will see how to record the signal into the Matlab. The recording of audio signals in Matlab can be done using a command also, or using an app also. So in command, many times what happens, it creates a memory and that is not deleted many times. Therefore, it is better to go to an app called Audio Leveler. Actually, this is not only for recording, but also it is used for labeling the audio, for marking some points in the audio signal. Therefore, this app is called Audio Labeler. The command you can write in the command window, or you can write in your script file. Then it will be opening an app in the application kind of thing, or interface kind of thing, where you can do some of the things. Let me click on this. Okay, this is the app, and this app have two tabs only: label and record. So because we are going to record, so we have to click on the record. Then we will see the labeling. First of all, we have to record. So therefore, I am going to the record function of this audio labeler application. You can see red button here. This red button is recording. You can record here. You can click on the record. Hello everyone, welcome to Matlab. Okay, so maybe a little late, but it have recorded. So here there is play button. On the play audio, I don't know, this is audible, but you see, audio level is less because I am sharing in Google Meet also. So my mic is being shared at two places, in this also and in Google Meet also. Therefore, okay, so therefore this label is less. Okay, so this is the plot of this audio, and this here you can see this. Okay, how means in the what format it will save to the files, you can select it here. FLAC is selected by default. You can select AVI, WAV, MP4, WMA, whatever you want. So WAV if I select, and then again record, I can also say that name also my voice. Any name you can give and then record. Hello everyone, welcome to Matlab. See, now this is saved as the my voice 002.wav file. Okay, so just I will right click and delete this, remove this from this disk. So just I am deleting this previous one. I'm just because I usually work with the .wav file, which was this was supported in the earlier version of Matlab also, but in the latest version they are supporting other MP3 files also, and this flag file, WMA, MP4 or OGG file, AVI files, all the files. But in the previous versions, only WAV file used to work. Okay, and now we can go to the label section. In the label section, one thing is there that you can do the speech detection. You can find out the places where the speech is detected, means speech is there. So you can just click. When we click on this speech detection, it will open a speech detector third level, which was not there in previously. Now you can see that we are checking the regions of 0.05 seconds, and then run this. When you run this, you can see that there are labels available below the waveform. True means the place where there is voice available, and blank means there is no voice. Then true means there is voice. When you click on true, it will select the particular voice, and then when you click on this, it will run only the part which is true, which is the selected. And if you select second one, and then if you run, then it will run only that part which is selected, that what is there in that particular part. So that particular part can be analyzed here. Okay, and you can see that is this is the label. If you want to delete this label, you can delete this label from here. Okay, there is one more tab here that shows the audio file information, means what is there in audio file and what is the how many channels are recorded. Here by default only one channel is recorded. You can change it to 2 channel if you want a stereo type recording. By default mono is selected in the recorder, so you can I will show you how can you specify it to. Here there is setting button. In the setting button you can convert it to this number of audio channels, then it will change. You can also change the sampling rate. Currently it is 44,100. Therefore this will show only 44,100. There is auto in which kind of data type. 16-bit integer is by default. You can change data type also to increase if you want to increase the efficiency or increase the precision in your audio file. Okay, so this is how we can do this, and this the same thing whatever we had selected while recording, because this doesn't know that whether this is recorded in Matlab or recorded in some other place. Just any file will come here and it will show the details of the file, that what is the duration, what is the sample rate, how many channels are there. For example, I will take one file from my directory. I will add one file here, load audio files. You can load audio file my voice .wave. This is 6.84 seconds, and this was 5.472 seconds. See, and if I execute this, this is a different recording, although the content may be similar, but this recording is different. Okay, so there is someone mic is on. Please mute yourself. Okay, so this is how we can do the analysis of file in this label detector and speech detector. Okay, so this you can give these files, and you can also give legend to this. That will channel 1 and channel 2 if the 2 channels are there. So here currently only 1 channel is there, so therefore only channel 2 is being shown. Okay, I will just close it.
I have one question. Could you please give at least one example of where we can use this kind of what you say as a this kind of techniques are used? Can you give an example?
Sir, in modulation techniques we can use, sir. So
modulation techniques?
Yes, sir. And for students we can teach.
Okay.
Voice information, speech signal processing. Lot of applications are there, sir.
I mean, whatever being explained, just to see the time of the speech, what are those peaks, etc. And this information can be obtained from any app available on the internet. So what is the special about the Matlab program that we've been using right now?
Yeah. I will like to say something. That what is the advantage here? That if you are doing some speaker recognition or some complex kind of things, and then the other app that can't do, and at that time every time you want to be going to the other app and then saving the data and coming to Matlab. So it is better to generate the data in the Matlab itself and to do the further processing, because here you have programming facility and on the other apps you don't get the programming facility like that. So therefore it is advantageous to get it in the Matlab itself rather than taking it from the other softwares. In other softwares, maybe more features available as comparison to Matlab, but their purpose is different. Here, our purpose is different because we are going to use it in the programming, connecting it to our programs.
So, are you going to show us how you will use your voice in the programming?
Yes.
Okay.
That is what I have just saved this voice, whatever we have recorded in the current folder.
Okay.
Then I'm going to show you some use in the program. How can we do plotting, and how can we do something in this? So today actually I'm just plotting, but in further class sessions I will be explaining its other uses, that how can we access some features of audio, and how can we do some analysis of this, how can we apply filter to this audio signal. Okay, so this was just a demonstration of basic audio labeler or audio. How can we record audio? I will also demonstrate some other audio programs, so that how can we read audio file. Okay, so if audio file is already recorded, this is not necessary that you record from Matlab itself. You may record from other software. If you have this file, you can read it. You can read it with the help of this command in this program. Like audio read, one function, one command is there. That command can be used to read the audio file. And this, for example, my voice.wav, this file is there in my current folder, and I can read it with the help of this command, my voice.wav. And what are these two variables? This is y will save the data of the file. I will just comment all those things. And also similar to my practice, I will write CLC clear and close all. Okay. So then what it is doing, it is reading the data, reading the audio file, my voice.wav, and it is giving us data, audio data, in the form of Matlab variable, and it is also giving us this sampling frequency of this. So this is the data which have this many numbers of data, and cross on this is actually the sampling frequency was 44,100. That is what we had selected. So the same frequency is coming here. If we want to play this in the using the command, using Matlab command, without going to any application, you can play it using the Matlab command. So yeah, this sound y, fs. Yeah, can you hear this? Actually, the voice is coming less. Can you hear this? Is this audible?
No, sir.
No. I think I had shared, but at the time of sharing, I have not shared this audio also. So I will share entire screen, and no. In Google Meet, they do not actually. There is no option that you can hear. Okay, so it will not be audible. But if you try in your system, it will be audible. I can hear it. For me, it is audible. But for you, I will say it may not be audible. But I can hear when I play. Yes. So if you do the same practice, like you save this file into the current folder, it should be in current folder. Otherwise, if it is not in current folder, then you have to give the path, like C colon, whatever your folder name
Please
is.
share your screen.
Yeah, I will show. Okay, so actually in Google Meet you cannot share the desktop audio, so it will not be audible to you. But if you do this in your system, you can really hear.
Can you please once show the file Y and what is inside there? It shows many rows and 2 columns. So I'm curious to just to see how your voice is being recorded into the mathematical numbers. So can you please show it?
These numbers, okay, I will show. See,
okay.
These are the numbers. Okay. Actually, 2 numbers are there, so you can see what the both are having same values almost.
Okay.
Because it is 2.
What are these? In the first column, what does it say? The first and second column, what are the meaning of these?
Actually, it's a stereo kind of recording. The recording is of 2 types. The recorders are of 2 types. One is mono and another is stereo. So this recording I have done in with 2 channels. Therefore, there are 2 values. And the second recording, this one, I will let us try for this that also. Actually, that I have done for only 1 channel. So let me do it. See, here only one column, because this recording I have done only for 1 channel. So a recorder had only 1 channel, so therefore there is only 1 column, and these are the values of amplitude.
What's the meaning of channel here?
Channel means the recording is a sensor. 2 sensors will work. 2 sensors will work at a time.
Okay. So actually, if I use 2 channels, meaning that my voice is being duplicated, right?
Yeah.
Okay.
So see here, because of that only in the previous data.
Okay.
In this data, because of that only they are having similar, almost same values, 2.13 and 2.44, 1.52.
But is there any rule that is governing how it is actually converting my audio into the mathematical numbers? Is there any rule for that, or it
yes, there is a complete protocol standards actually.
Okay.
That how the data is converted into how the voice is converted into data. For MPEG, MP3 or MP4, this is having a complete protocol of encoding, is encoding and decoding. That how so this is actually complete algorithm that is previously defined. That is why we define that WAB in which format we want. So these are the standard formats of decoding from a physical signal to a particular number. So that is what it means. That is why there are these extensions WAB, JPG, or MP3, MP4, or AAC. So because they have different algorithms of decoding, encoding. Sorry. So that is what it means. Okay. So let us do this thing.
So there is a question. So there is a question. What is sampling frequency here?
Sampling. What is the meaning of sampling frequency? That how many samples we are taking in 1 second. How many? Because here is 44,100. That means in 1 second, the sensor is taking 44,100 samples from the audio voice. Whatever I am speaking from my speech, in 1 second, sensor is taking 44,100 data. That is the meaning of sampling frequency. Okay, so this much data is available. If you divide it by 44,100, that many seconds are there. So if I divide this 241,307 by 44,100, that means this is 5.4737. That means my voice is recorded for the time 5.47 seconds. Yeah, got the point of what the meaning of sampling frequency. Anyone any other? This UP Verma. Do you have any question? Mike, whose mic is on? Any question? Any query further? No.
No,
Okay.
sir. No questions in chat box.
Very nice. Then what I'm going to do this. I'm going to use this sampling frequency further in the same program. That if I want to use only a part of my audio file, I don't want to use complete part of my audio file. For example, if I want to use only some part of this 5.47 second, only 2 samples if I take, then it will be only a clipped part, not complete file. So I will just uncomment this one and see only 2 samples I am taking. Means 2 times of this 44,100. Okay. No. This is the sampling frequency. This is not maximum signal frequency. Signal frequency cannot be, audio frequency cannot be such high. Yes, Saran. This cannot be.
No, sir. I am saying that sampling frequency is nothing but Nyquist rate. We have to consider the Nyquist rate. Voice signal is 4 kilohertz for a human being. That into 2 will be 8,000 samples for our voice information. For audio, they are considering CD data rate, sampling rate. That is 44100. For CD rating and all, you use this sampling rate.
Yes,
this is
for CD writing we have to use this rate. Yeah, you are right. You are right, ma'am.
Yes, sir.
For CD writing we have to use this sampling rate. Therefore, this is one standard data rate. And actually, we don't need this much.
So for audio, we are having 20 kilohertz, right? That into 2 maximum they have considered 44K. That's it.
Yes, we can do 20 kilohertz also. This should be greater than the signal frequency.
Yes, sir.
2 times of signal frequency, that is Nyquist.
Yes, sir. That is what I have written. Maximum signal frequency into 2, greater than that will be the sampling frequency. Otherwise, you cannot reconstruct or retrieve the signal back.
Yes, you are right. That this sampling frequency should be greater than 2 times of the maximum signal frequency. So that is what one Nyquist criteria that we have to always follow. Otherwise, it will not be right. Okay, so that is here I am taking 2 times because just I am taking 2 of some part of this. Then I will read it this with this only this much. I am reading again only the 2 samples. This 2, not 2 samples, only the time of 2 sampling frequency. So it will be 2 seconds because one second, 1 sampling frequency. Means in 1 second data, and 2 sampling frequency is 2 second data. So I'm just
so you have done upsampling or downsampling, something like that.
No.
You have skipped one samples. You have skipped 1 samples and then you have considered 1 sample.
No. I'm taking only 2. Not only 2 samples. I'm taking the samples 2 times of sampling frequency.
Yes. I am saying like upsampling or downsampling, like that only you are doing.
No, it's not upsampling. I'm just reading the samples of 2 second data. 2 second data. Only 2 seconds. 1 second means 1 sampling frequency. 2 second means 2 sampling frequencies. So I'm taking 2 sampling frequencies time. So that is why. Then let us do this. If you are practicing the same thing, you will see that only some part will be played, not all complete part. Only 2 seconds of your recording will play. Okay, then this is what I wanted to show, that we can read the file that we have created. Okay, next thing is that we can write also. Similar to the audio read, there is a program or command for audio writing also. You can write the audio file in your directory after processing, after doing filtering, after doing some analysis, after doing clipping some part, after taking some data out from your audio data. You can do anything now because it is available in Matlab. In Matlab, every pixel or every sample is accessible. You can change the sample, you can do encryption, you can save some message into the audio. In fact, I have done one project in that we can encrypt the some. We can save some data in between these 44,000. We have many lot of samples, so we can do encryption in between also. Anyway, so by info command, audio info, you can get information about this file. If you don't know what is in this file, how much long it is, what is the sampling frequency of this file, any file that is available in your current folder. If it is available in your current folder, you can directly write like this and then run this. Then it will show you the date information that what is the sampling frequency and what is the duration. This is the exact duration what we had calculated. Okay, and these many samples have been taken in this time. Okay, so this is recorded up to 5.4718 second, and this file is available in this folder and uncompressed because compression is not there. Number of channels are 2. That is what I was telling, why data two columns are there, because it have 2 channels. It is stereotype. You might have seen stereo, mono in options available in the audio setting of your video recorder or something, that we want to record audio or mono or stereo type. So that is only generally 2 channels are maximum in the recording. So that is a stereo kind of recording. Okay, so duration, this is the title, comment, artist name. This is not available in this file. If you save this, then it will be added to the file. You can add this info also. And number of bits per sample, then which kind of data type is there used for this. So 16 bits because it is of double type. Therefore 16 bit data is used for, 16 bits are used for this file. Okay, this way you can get information about the file. Same information was available in the app also, but if you don't want to go to app, you want to use command, then you can use this my audio info command for this purpose. Next is audio labeler. Already I have discussed with you. Okay, then let us go back to this one, audio read. So you can do audio read. There is audio write command also. So I will whether I have saved it, because today the purpose was just to show you how can we display the data, signals, how can we represent signals, audio signals, ECG signals, if signal is available in Excel sheet, if signal is available in the text data. That's what was the purpose of talk till now. There is one more thing to discuss, that is how to even one more audio test bench is also there. So that that thing you can do, that how to one more app available that is called audio test bench, where we can do some kind of testing. So these are the apps of Matlab related to audio. So you can just click on this. You can type this command in command window, audio test bench. You have to take care of capital and small, that audio is small, then test, in test T is capital and bench B is capital. Okay, so just when you type this command, it will open. this one. This is audio test bench. Here you can test, you can do some spectrum analysis of audio signals. You can take any input signal. You can configure the selected input. You can take any object. Under test means any signal from the folder. You can browse Matlab. You can take any CC audio plugins here. Okay, sorry. Okay, so you can select any input here. One input from audio file reader, or you can take some, and then you can select audio file. See, many files are available in the. This is in the toolbox, but will go to our work folder, and my voice I will select, and then open. This audio file is reader is now selected, and then let us run this. Okay, so just click on this. This will open a scope, and then run it. It will show the file in the scope. See, this is showing the file in the scope. Otherwise, if you don't want to select your file, you can use the spectrum analyzer to see the output. This is the spectrum analyzer. The frequencies of signal in kilohertz. You can see up to 10 kilohertz. It's going in this 1 kilohertz. So that can be seen here. Okay, so this is the way we can do the little analysis of signal. If I take a chirp signal, and chirp signal is standard signal available here itself, and then run this. It will okay, so in this way you can do analysis, some test bench, or so you can test any signal. You can write. So audio device writer, audio file writer. The audio file writer you should select, and if you want to save your output, then you can save your output here, and whatever kind of compression you want to select, you can select here, compression type also. Okay, so this is what is the audio test bench, where you can test the audio, you can check the spectrum of the audio signal, and you can do save the analyzed signal into that. Okay, so these are some signals, representation of signal, and we can perform simple operations like convolutions. Here I have given one example of convolution. So for convolution, this is a simple linear convolution of two sequences. Any sequence we can take, because here I have taken input command. I am taking input command, CLC close and clear, I usually write, and then input command, so that you can take input manually. So any input can be taken for X, then it will show enter the first sequence, then H equal to input, enter the second sequence. It will show, ask you to enter the second sequence, then CUNV X comma H. This will do the convolution. Okay, so we will go in it further. If there is any question, from the discussion till now, I would like to answer.
Sir, these functions are not available in Matlab 2014 version.
Which version? 2014. Which
Yes,
function?
Sir, audio level.
Audio leveler will not be available because in that version this audio leveling was not there. So some other 2014 it is not available. 2016 it is available. Some of these functions are new, so that were not available in the previous version. Any other query? You can just unmute and speak.
Sir, can you show how the convolution of this in step by step?
Okay. The convolution can be done step by step. I will show it. How to perform. So for that you have to just make a loop. Just because we have not introduced loop here, therefore I have not added the convolution just by in step by step. So that is why, but we can do, and there's no problem. Or otherwise you can also go inside this CONV, not COV. You have to, you can understand it's okay. So convolution, first of all we have to understand what it's yes. Yeah, it is inbuilt function is also available, and also we can write function that how to do convolution in step by step. There is that is not an issue. I think it will be discussed in the next session how to do step by step convolution, because it will take some loop kind of understanding way. I have to make otherwise I have to make a function, writing a function.
Shifting, reversing, and then shifting, then multiplying, sir.
Yeah, but it has to do be done recursively.
Yes, recursively we have to do.
Not one time. So we have to make a loop, and in the loop
yes, sir, yes, sir.
have to be done. So I'll discuss this in the next session, or we can do in the practice. I will share in the practice sheet how to do it one by one. And currently I will not go in that because this time. So we can do this later on. If any other question query there, then that we can do.
Sir, actually, I want to interface my AD8232 ECA sensor from the Matlab. So how can I interface this sensor to the Matlab?
You can see if you want to interface any sensor with the Matlab, then first of all you have to download the libraries for the Matlab. If your Matlab can support that library particular, so that if other thing is that first of all you search in the Matlab documentation whether they have the driver for that particular hardware. For example, if you want to connect Arduino, then Arduino driver should be installed in the Matlab. Then only I can interface Arduino with Matlab. So if yours this hardware, which one?
8232 ECG sensor.
Yes. Then you have to first of then download that driver, and then you can interface it to Matlab. Otherwise, if your sensor ECG sensor is giving the data, it is giving data.
Yes, sir. It gives the ECG data.
ECG data, then you can directly import that data into the Matlab. For the live transfer to Matlab, you have to explore it. That whether the integration with the Matlab is available or not. Because Matlab do not support all the hardwares. It supports many hardware, but all the hardwares are not supported. So you have to search it out that whether this hardware is supported or not.
Okay, sir. Thank you.
So how will you support for real-time audio, sir?
Yeah, real-time audio also. The audio sensor is interfaced or not. We have to install some drivers, or we have to look at continuously. How can we get it continuously? It creates problem in Matlab. I had tried for real-time audio, but it creates problem because the data directly coming to the Matlab becomes so large that the memory allocated to Matlab becomes full, and it creates problem. I tried it to get into Matlab. So live audio is difficult, but audio recording for some limited time is possible. Is a good, means is not. It will not create any problem. But if you are recording continuously live, then it will be a problem.
Hello, sir.
Yes.
Hello, sir. One thing.
Sir.
Can we do all these processes for the reverse manner? Means if we are getting the signals, and can we get it in audio form?
Yes, we can. If we have only a sinusoidal, if you are creating a sinusoidal data, can we convert it to audio?
Yes.
That is what your question is. That is also a very nice question. That if I have any data available by some analysis, or we have created some data, then can we save it as an audio file? Yes, we can save it as an audio file, and we can show that there is a you can see audio write, simple command. Audio write command is there for writing data into audio file. You have to just provide the sampling frequency. So any sampling frequency can be chosen according to our convenience. That is, for example, if we have a sinusoidal data,
okay,
then suppose we have
Sir,
some
your
data.
screen is not visible if you are sharing.
Let me share. Okay. For example, I create x equal to 1 to 1 colon 0.01 up to 10. So this is actually data created in Matlab. Number. Okay, so some data is created in Matlab. And I will take some FS sampling frequency, let us take 1000 for 100. Some frequency had to be taken. Then audio write command can be used. After audio write, you have to give the file name, that my data, your data voice, data to voice, whatever name you want to give, that name, dot WAV or dot MP3, any file name can be given. After that, we want to save X, and then some sampling frequency should be taken for, because it is audio, so some sampling frequency should be given. And when you run this program, it will save one file into your current folder. See this, my data voice.wave. This is actually a file of audio file that can be run into VLC player or any other player. So you can generate voice also. Extended voice signal, extended noise signal is also generated. You can also generate noise and add it to your other file. There are standard functions for generating noise also. Sir, is your query answered?
Yes, sir.
This was the query. How can we save into?
Yes, sir. Yes, sir. This was my.
Yes. Okay. Any other question?
Sir, there is a question by.
So can you show me the plotted
plot of this? Which plot?
Hello.
Yes.
A plot of that signals you had shown and how to get it in the audio form.
Audio, which simple plot? So this will be X data. So currently this is a simple data.
Yeah.
This is not an audio. This is because data is just a linear data. So it will be like this one. To 2021B, which Matlab version we have to use. So Matlab version, see, whichever version you have, you can see the basic functionality will be available in all the versions of Matlab. Most of the functions like this audio read and audio write and this whatever programming I am doing, that will be available. It may be possible that you don't have these applications like audio labeler and test bench, audio test bench, etc. But most of these data means programming function will work. In the very earlier version, if you are going then before 2014 or 2012, or then instead of audio read, audio write, command was wave read and wave write, because only wave files were supported. That at that time Matlab had command wave read and wave write. Currently, most of the audio files are supported. Therefore, they have changed the command to audio read and audio write. Okay, so just basic difference is there. Otherwise, this command will also work in the most of the recent 5 years Matlab programs. Matlab. Any other question?
So there is a question by Anandi. Can we detect the sampling frequency of any signal if its sampling frequency is not known to us?
Yes, this is also a good question. That how can we know the sampling frequency if it is unknown to us? So for that, I had shown one program where there was a command called audio info. Audio info command can be used for just a simple command is there. If there is a audio file, then sampling frequency is not for all. See, all the files, all the data do not have sampling. Sampling is available only for the data which is sampled from the physical quantity, like ECG, audio, PCG, or something, temperature, or something coming from the physical signal. Otherwise, sampling is not required. So sampling will not be available. So audio info command is there, which can be used for audio files. So if I don't know what is the sampling frequency of, let me clear this. Otherwise, you will say, sir, right side this was showing, and I have cleared all the data. I don't know what is the frequency of this.
Sir, your screen is visible. Please share the screen.
Available, sir. Kindly, sir.
Yeah, I will share. I will share. Okay. See, suppose we want to know the sampling frequency of this my voice.wave, then the command is audio info my underscore voice dot wave. Whatever file is there, you just want to get the information about this file. It will show you information. What is the sample rate? This is the sampling frequency. You will know the sampling frequency beforehand. I have not imported the file into my Matlab. Before that, I have just put a command audio info, then file name. It will show you the information of the file. What is the file? How many channels are there? What is the sample rate? How many samples are collected? What is the duration of that particular file? So that is the way of knowing the sampling frequency beforehand. Many times this question becomes much more critical when we are going to save the data, and as a audio file or as any sensor file, any important file, and then we need to select a sampling frequency. So at that time, the rule is that you should follow the Nyquist rate. That sampling frequency should be greater than the frequency of the signal. Whatever signal you are using, for the sampling frequency should be greater than 2 times, otherwise signal will be distorted. Yes, it should be greater than the Nyquist rate. So at that time you can decide the sampling frequency by your own and save the file. Very nice. Nice question. Any other question?
So there's a question by Dr. V. Sai. We can use FFT to find it, the sampling rate.
Yes, that is also right. We can do the transform. We can
so
use
from
FFT
the
also.
spectrum itself we can analyze. No, you have shown the spectrum.
Yes.
In the spectrum,
yes,
we can find the frequencies, the maximum frequency how to consider.
Analyzer also. Yes, very nice. We can see the spectrum analyzer and we can get the sample frequency. Also, by transforming, like Fourier transform, FFT, DFT, also we can know the sampling, the frequency of the signal, then we can decide the frequency of sampling. Because FFT will give the frequency of signal. And for sampling frequency, we have to go to that only. Okay, then we have to decide it. Okay, so I think this much is sufficient for today, and we will share the handout also with you.
Sir,
the recording also.
Yes. Sir, color noise. What can you say something about color noise, sir? In that
color noise.
Yes, sir. In that audio test bench. Yeah, so you have shown that audio test bench.
Yeah, color noise
color
is
noise.
also there.
Yes, sir.
Yes. So actually, that is a part of the noise analysis. So white noise and color noise. So therefore, I have not discussed that. Okay. So in the test bench, there is a testing facility for that also. There was audio.
Hello.
Yes.
Have we used the third dimension, that is time? If suppose all these signals are recorded in space, so the 3D plotting can be possible.
Yes, 3D plots are also possible. We have not discussed. I think, sir, have you joined my previous modules in this sequence? No. Okay. So actually, there is possibility of 3D plotting in Matlab, and very nice 3D plotting is available. And because this was not part of mesh command is one one way. There are 10 ways of 3D plot, 10 different kind of 3D plots available in Matlab. So I will share one link in Google Classroom for 3D plotting. So the third space also you can do 3D plotting. So I think Panda sir, we can share 3D plotting link in the Google Classroom, so that if anyone wants to learn 3D
Yes,
plotting,
sir.
then they can learn. Yes, Kapil, mass command is is there for 3D plotting. Yes, that is all. Plot 3 command is also there, and surf command is there, and this ribbon command is there. So many commands are there, but according to the requirement, which kind of plot is required by that gets used. Okay, so it was a nice and very interactive session. So really, I enjoyed a lot. You all have asked nice questions. Yeah. So we can.
Thank you, sir.
Thank you all. Yes, sir.
So this is, I have some questions, sir. I mean, suppose the time domain signal from the oscilloscope. I mean, can we do the filtering using different kind of filters? I mean, Butterworth filters, like filters. How can I use this Matlab tool?
Sir, I think we have DSP tool for filtering.
No, in Matlab, can we use
Yes,
that?
sir. Yes, sir. We have tool for DSP tool. Digital signal processing tools is available for designing filters.
I mean,
we have to consider which frequencies the noise is coming. We have to filter that based on the design, sir.
I mean, are you telling, madam, in this model? I mean, 2021 version or old versions?
So we have a DSP tool available in Matlab, sir.
Okay.
Actually, I missed the question. There was some problem in my network. So, what was the question, sir?
See, he's asking about Butterworth filtering, Chebyshev Butterworth filters.
Yes, yes. We are going to discuss that filtering in coming session. Filtering is separately. Butterworth, Chebyshev, FIR, IIR, all those things are there. There is separate toolbox, DSP toolbox in Matlab, and also there are apps for plotting, so or for filter designing, and we can also convert to VHDL code that can directly that directly can be accessed in the Xilinx for plotting the filters for generating codes. That is there. So I will cover that in the coming session.
Super, sir. Thank you, thank you.
Any other?
Sir, which version it is supporting for VHDL, sir? Conversion for VHDL. Xilinx.
See, that is available in the earlier versions also.
Okay.
Just HDL coder is there. So that supports the coding conversion to VHDL. But I tried the conversion, so that was not optimized.
Okay. Anyway.
So, but that is not optimized, but you can get the code, VHDL, equivalent VHDL code. I usually use the coefficients. We don't convert complete code. We convert take only coefficient in the format of VHDL that is compatible to VHDL Xilinx, because all the formats like floating point and these all not convert compatible to all the FPGAs.
In terms of Verilog or VHDL, sir? Both is possible.
Both is possible.
Okay.
Both is possible. Though there is selection option, so that can be, yes, that can be done. So that is available in the there is one tool, FDA tool is there in Matlab, so that can be used in that that I used for converting to HDL, for analyzing the filter in the HDL, for the timing, for power consumption, like that. Okay, so I think the time is over now. And
yes, sir. We are ending. We are at the ending of session.
Thank you all. Thank you for a nice discussion. Actually, this was a very wonderful session, and You all are asking so nice questions.
Thank you, sir. Thank you so much, sir.
It was a very interactive session, sir, actually. Thanks to all for such an active participation. We want such kind of participation in upcoming sessions also. If we have some specific view regarding the sessions, you can post your suggestions or anything in our WhatsApp group so that we can consider if possible that in our next lecture, if possible, that will be better. Because instantaneous, it may not result too much, but if you suggest some sometime before the lecture, it will be quite beneficial. I think it is enough for today. Thank you, sir. Thanks for a nice, and actually it is quite dedicated to a particular field. So I think it is a very nice session.